Hello everyone, welcome to Microcontrollers tutorial. Myself Dr. Naveen Kumar R. I've been working as assistant professor in Department of Electronics, Ramai College of Arts, Science and Commerce, Bangalore. In continuation with a few lectures of microcontrollers, today I'm giving you a lecture on microcontrollers with Unit 1, which is prescribed by Bangalore City University for BSc 6th semester electronic students. So we'll start from the Unit 1, and the Unit 1, it consists of a basic definition and gives you a fundamental background for microcontrollers. So therefore it is a very essential to learn about the basic fundamentals of microcontroller. So if it will come to a microcontroller, so what is a microcontroller? So in order to learn this microcontroller, we have to recall some concepts of microprocessor. What is microprocessor? Microprocessor, as we know that it is a VLSI chip. It is used to process the binary informations according to the program which is stored in program memory. Or you can simply define the microprocessor as CPU on a chip. CPU on a chip, that is central processing unit on a chip. But microcontrollers, it is advanced version of microprocessor, because it has some advanced features like inbuilt memory and some IO ports and some peripheral devices. That means including microprocessor, it has some inbuilt peripheral parts. So in this digital world, we can see the microcontroller everywhere. That means from small micro devices to a large mega devices you can observe. That means this microcontroller is utilized in various applications like drones and defense field, and in automation field, even satellite applications also. Therefore, it is very essential as electronic students to understand about the microcontrollers programming. Let us see the definition of microcontroller. So microcontroller, you can define it as the computer on a chip, or in elaborated definition as a special purpose computer chip used to perform specific single task. We can see here the block diagram of the microcontroller, but this block diagram is related to 8051 microcontroller, but it is similar to the general block diagram of microcontroller. Here you can see the CPU is a central part of this microcontroller, hence it is called as a computer. Why we call this microcontroller as a computer? Because it has all the peripheral devices including CPU. The CPU is nothing but a microprocessor. It has ALU, register units, timing and control unit, and interfacing units. Including the CPU, inside an integrated chip, some of the peripheral devices like memory, small amount of memory, RAM and ROM, and the timer circuits, serial ports and IO ports, and the bus controller, interrupt controllers and oscillators we can observe in general block diagram of the microcontroller. Okay. So small amount of the program memory, that is ROM, that is 4 kilobyte for 8051 and 128 byte for data memory for 8051 microcontrollers. And the timers, 2 timers are there in 51, but in case it may be in different families, the number of timers may be vary. And serial ports, in order to transfer any serial information from CPU to external devices, we are using utilizing the serial port. And IO ports, in order to communicate with the IO devices, here 4 numbers of IO ports are there. It also may be vary, depends upon the family. And bus controller. So bus controller, what is the use of bus controller? So bus controller will controls or synchronize the operations between internal peripheral devices and external peripheral devices. And the oscillators and interrupt controller. Oscillators is a device which will generates the timing cycles or oscillations to CPU, means clock pulses to the CPU to perform an operation. And the interrupt controller, because various interrupts will be generated inside the circuit or it may be generated from external devices, that will be controlled or synchronized through this interrupt controller. And it is very significant to learn the comparison between the microprocessor and microcontroller. Here you can see there is a difference because microcontroller is advanced than that of microprocessor. So let us see what are the advancement you can observe from fundamental microprocessor. So in microprocessor, it is by the definition we know that it is on chip CPU and the microcontroller is an on chip computer, and it doesn't has on chip CPU, on chip RAM, ROM, timer and IO port. But microcontroller has on chip RAM, ROM, timer and IO port. Means what I told, here there is nothing inside the chip except the functional blocks of CPU. But here including microprocessor, various peripheral devices are connected. And the microprocessor, it has high power consumption, because in order to connect any external peripheral devices you need external power supply, therefore it consumes high power. But here there is no need of any peripheral devices. Small scale peripheral devices are already inbuilt inside the integrated chip, therefore consumes less power. Pins are unifunctional, means less number of ports are available and those pins are utilized for only one applications. But here it is multifunctional and pins can be utilized for both the IO or memory or any applications. And in microprocessor, fifth comparison, few bit related instructions are there, many bit related instructions are there. That means the more number of bit related instructions are available, then the microcontroller program will become more versatile than that of microprocessor. Requires more hardware for interface, as we know that there is no on chip peripherals, hence it requires more number of hardwares in order to create an interface. Here less number of interface devices is required because it has inbuilt devices, inbuilt peripheral devices. And operating speed is high, obviously, because in microprocessor there is no interconnected peripherals inside a chip. The CPU will operate with a high speed, performance will be very high. But here a small delay will happen by communicating with other peripheral devices, therefore operating speed is very low compared to microprocessor. So these are the basic comparison between microprocessor and microcontrollers. Let us come to the classification of microcontroller. So microcontroller classification, it is depends upon the various factors. That means based on word length, based on memory devices, based on instruction set and based on memory architecture, we may classify, and manufacturing industry, we can classify the microcontrollers. Based on word length, you can classify it into 4, 8, 16 and 32-bit microcontrollers. So what is this word length? So word length means it is a size of or maximum number of bits that can be handled by your microcontroller. If microcontroller can able to handle 4 bit of information at a time, that is called as a 4-bit microcontroller. And if it is able to handle 8, 16, 32, that will be call it as their word length or bits. And based on memory board devices, either it may utilizes an external memory, then it is called as a external microcontrollers, or if the memory can be expanded or application, it was defined as a embedded microcontrollers. And instruction set, CISC and RISC, so complex instruction set computers and reduced instruction set computers. So complex instruction set has, the name itself defines that it has large number and very difficulty to program. So instruction sets are very complex. And in RISC, it has very less number of instruction set and very easy to program. And the memory architecture, Princeton and Harvard architecture, based on the program memory and data memory partition, we may classify the microcontrollers. But based on manufacturing industries, here you can observe that 8051, Motorola, PIC, Texas, National Semiconductors, or and other, and Atmel and Dallas, Philips and Siemens are the various manufacturing industries. They are providing various microcontrollers and which has some unique codes. So basically 8051 is a Intel manufacturer industry based microcontroller. So in syllabus it was clearly mentioned about the classification based on word length. So I am focusing on the classification based on word length of the microcontroller. So word length, I told that it is a maximum information that can your microcontroller can handle. Okay, what about 8-bit microcontroller? It can able to handle 1 byte of data at a time, means 8-bit of information at a time. It can process or handle 1 byte of information at a time. So it has 8-bit ALU, 8 megahertz clock frequency, example 8051, and 16-bit microcontroller which can handle 2 byte of data at a time, 16-bit ALU, 16 megahertz clock frequency. Example is Motorola 68HC 16Z3 series. And 32-bit microcontroller, it can handle 4 bytes of data. 4 byte is nothing but 32 bit of data at a time, and it has 32-bit ALU, 32 megahertz clock frequency, and the Motorola series of 68000 will belongs to 32-bit microcontrollers. And very most commonly utilizing microcontrollers are, here we can observe the comparison of most common microcontroller families, that is 8051 microcontroller, 8052, 8031. So these are 3 microcontrollers we are using in many applications. So the common features here, it was based on ROM capacity and RAM capacity and number of timers and number of IO ports and serial ports and interrupt sources availability. These are the features we have been selected to compare these 51, 52 and 31 family. We can observe here 51 has 4 kilobytes of program memory, and 5.2 has 8 kilobyte, and 3.1 has 16 kilobyte. And RAM capacity, that is data memory capacity, is 128 byte in 5.1 and 3.1, and 256 byte in 5.2. And 5.1 and 3.1 has same features of number of timers, number of IO ports, number of serial port, and interrupt sources. But 8052, which has 3 timer, 32 IO port, 1 serial port, and 8 interrupt sources. And a few Atmel family microcontroller comparison is given in this, tabulated in this table, with the same features like RAM, ROM, timers, IO ports, and interrupt sources, and power consumption, that is VCC, that is how much of voltage it was consumed. And here you can see that 89C420 Atmel, and 89C440, 89C450, and 89C51, 89LV51, 89C1051, and 89C2051, and 89C252. So among all these microcontroller family, so if you are based on your application, program size, and requirement of timers and peripheral devices, you can go for this microcontrollers. So if you are having less number of program size is very less, you can go for 89C1051 Atmel microcontroller, because it has very less program memory and less data memory, with the only limited timer, that is only one timer it has, and 15 IO ports, and interrupt source are very less. If you want to go for, if your program has a large number of size, then you can go for 89C450 Atmel family, because it has 64 kilobytes of ROM, that is program memory size is very high. Therefore you can go for this family for building any modules. So you can build any modules of applications by selecting suitable microcontroller family. Therefore it is a very fundamental requirement for a programmer to understand the features of microcontroller, then only he can opt suitable microcontrollers for the application programming. So this is about the fundamentals of microcontroller. So once again I'll repeat this concept. That is, we discussed about a microcontroller. So microcontroller is a computer on a chip, a special purpose, or you can elaborate it as a special purpose computer chip used to perform a specific single task. And it includes the CPU with small peripheral devices like small amount of memory, timers, IO ports, serial ports, and bus controllers, oscillators, and interrupt controllers. And the fundamental comparisons or differences between microprocessor and microcontrollers we can observe in the 7 points. And the microcontroller classification based on word length, memory, instruction set, memory architecture, and manufacturing industries. And limited classification with the word length of 8-bit, 16-bit, and 32-bit were discussed. And comparisons of most common microcontroller families of Intel and Atmel microcontroller family were discussed. So in the next lecture we are going to discuss about the microcontroller 8051.